Hey guys, in today's video I'll be going over distributed forces, centroids, and first moments of area. In this video I'll be going over a couple of problems. And remember, if you have a specific topic you want me to cover, let me know in the comments below. Thank you for listening, and let's get on to the first problem. For problem 1, we need to find the centroid and first moments with respect to the x and y axes. So for the first step, I like to break down the composite figure into simple geometric shapes. Number 1 is a triangle, number 2 is the overall square, and number 3 is the semicircle. Before we get to the table, there are a few things that we need to know first. That's x bar and y bar, which represents the coordinates for the centroid. In the case of the triangle, we have the base over 3 for the x bar and height over 3 for the y bar. The square is relatively simple. You have the length over 2 and the height over 2. And finally, for the semicircle, the x bar is equal to 4r over 3 pi and y bar is equal to r. What I like to do for these problems is make a table, because it's way easier to stay organized and come up with the solution. So I'm going to go ahead and start inputting the values. We have the area for the triangle is base times height divided by 2. In this case it will be negative because you're subtracting the area, so you'll end up with minus 9 millimeters squared. The area for the square is length times width, so you'll get 100. And finally, the area for the semicircle is pi r squared divided by 2 because it's half a circle. And it'll also be minus because you're subtracting the area. So the centroid of the triangle in the x direction is equal to base divided by 3. In this case, the base is equal to 3 millimeters. But since it's not at the origin, you need to subtract the total length minus what we calculated to get x bar. So to put it into perspective, you need to subtract the total length, which is 10 millimeters, minus our calculation, which is 1 millimeter. So this will give you 9 millimeters for x bar. We do the same thing for y bar. The height, which is 6 millimeters divided by 3, gives you 2 millimeters. 10 minus 2 millimeters gives you 8 millimeters. For the next two columns, we multiply the area times the x and y coordinates of the centroid. So this gives you the x and y bar for the square would both equal to 5 millimeters. And this gives you 500. And finally, for the semicircle, the x bar is equal to 4r over 3 pi. So x bar is equal to 20 over 3 pi, and y bar is just equal to 5. And multiplying this out, you get ax bar is equal to minus 250 over 3, ay bar is equal to minus 125 pi over 2. So for the next step, we can sum up the area. We can sum up the area times the x bar, and also the area times the y bar. So hopefully my math is correct. So summing up these three columns, we get the area is equal to 51.73. The area times x bar is equal to 335.66. And the area times y bar is equal to 231.65. So the first moment of the composite shape is equal to the first moment of area for the x-axis is equal to the summation of the y bar times the area, and that gives you what we solved for already, and that just gives you 231.65 millimeters cubed. And the first moment of area for the y-axis is equal to 335.66 millimeters cubed. The equation to solve for the x component of the centroid is equal to So x bar is equal to approximately 6.49 millimeters. And the equation to solve for the y component of the centroid is equal to and finally, y bar is equal to 4.48 millimeters. So there you have it, guys. We solved for the first moments with respect to the x and y axes, and also the centroid. Alright guys, that's it for today's video. If you found this video to be helpful, let me know in the comments and like this video so I know to keep on making these. Also let me know if you want me to cover any other topics. Thank you for listening, and I'll see you in the next one.